Hi everyone. In this video we're going to talk about the quadratic formula and how I can use it to help solve quadratic equations. Alright, so in class we've actually seen what the quadratic formula is, but I want to give a little bit more of a background in this video. So oftentimes what we're going to be doing is we're going to be trying to solve equations that have an x squared term in them. And in fact, polynomial equations where x squared is the biggest term. And so this is a case where using the quadratic formula is going to be a direct route that always gets us to a solution to our problems. So what that means is if I can rearrange an equation so that I have a term ax squared plus bx plus c, if I can ever make an equation look like this, specifically equal to 0, then the quadratic formula is going to be a way that I can figure out what my solutions are. And so if we're going to have a formula for this, we know what we want to know is what do I have to plug in for x to make this equation equal to 0? And so the equation is going to rely on a, b, and c. So depending on what those numbers are, we can come up with solutions, which means what do we plug in for x to get something equal to 0. And so what we've seen is that the solutions to this are given by the quadratic formula. So if I want a solution, it looks like this: x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay, and so what I have is over here on the left, my a, b, and c are the same as these a's, these b's, and c. Okay. So let's look at a specific example and see if we can use the quadratic formula to find the solutions. So let's take a look at this. 2x squared minus 5x, sorry, let's do 2x squared minus 9x plus 10 is equal to 0. So the first thing that I want to do is I want to go around and figure out what my a, b, and c are. So the first thing I have is that the coefficient that is in front of x squared, that's my a. Okay, so a, in this case, is equal to 2. So I see that because this number that's in front of the x squared is a 2. My b term is going to be a negative 9. So I see this, the number in front of the x, that's my b term. So b is equal to negative 9. And then my c term is the constant that's out here on the end, is a positive 10. So c is equal to positive 10. Alright, so using the quadratic formula is as easy as this. I'm going to take these numbers, 2, negative 9, and 10, right here, 2, negative 9, and 10, and I'm going to plug them in to this formula. So anytime I see a b, I'm going to replace it with a negative 9. Anytime I see an a, I'm going to replace it with a 2, and anytime I see a c, I'm going to replace it with a 10. So what we have here is my solutions take on this form. X equals, well, negative b. Okay, so we have negative, then I need a b term, so that's negative 9 plus or minus the square root of, okay, we keep going, so we have a b, right? So this is, I have a b squared, right? So what I'm going to do is I'm going to put in my squared term. And then my b here is negative 9, negative b plus or minus the square root of b squared. And we have a minus 4. And then a, well, that's a 2. And then c is 10. Okay, so I'm going to make sure all of this is under the square root. Now, here's a key. We're going to take everything. This is all of that I've written so far as the numerator. And it's all divided by 2 times our a which is 2. All right, so we've done a lot here, but what we should notice is that this is all numbers. So we can come down, and here's my equation. 2x squared minus 9x plus 10 is equal to 0. And if I simplify this, we should find that I get my answers that I want. All right, so let's take it one step at a time. So the first thing that I see is I have minus negative 9. So I have two negatives, that's going to be a positive. And so as I'm moving down, minus negative 9, this becomes a 9, plus or minus the square root. And then I'm going to see if I can take care of everything underneath the square root. All right, so first thing, negative 9 squared. So negative 9 times negative 9, that is 81. So this is 81 minus 4 times 2 times 10. So 4 times 2 is 8. 8 times 10 is 80. So I get an 80 over here. All divided by 4. Okay, so we're going to keep going. Give ourselves more space. We'll scroll down. So 81 minus 80 inside of my square root, this is 1. So my answer in the simplified form becomes 9 plus or minus the square root of 1, all divided by 4. Well, the square root of 1 is 1, so I get 9 plus or minus 1, all divided by 4. All right, so now we have to do some interpreting for what this means. So 9 plus or minus 1 over 4, this is telling me that I have two solutions, 9 plus 1, all divided by 4, or 9 minus 1, all divided by 4. Okay, so I get two things. My solutions to this are 9 plus 1 divided by 4, or 9 minus 1 divided by 4. Okay. Well, 9 plus 1 is 10, and 10 divided by 4 is 10 fourths. Okay, so 10 fourths or 8 fourths. Right, so 9 minus 1 is 8 over 4. And so what I see is that 10 fourths, if I reduce that fraction, I get 5 halves. 8 fourths, if I reduce that fraction, I get 2. Okay, so what this tells me is the solutions to my quadratic equation. Now, my quadratic equation is way up here. So the solutions to this quadratic equation, 2x squared minus 9x plus 10, are, down here, 5 halves or positive 2. So if I wanted to know the solutions, we have this here. All right, so I'm going to pause the video and let's bring up a Desmos window. Let's see if we can make sense out of this in Desmos. Okay, so we're back. We have our information up at the top. Our equation was 2x squared minus 9x plus 10 equals 0. We were looking to find the solutions to this equation, and the quadratic formula told us that way our solutions were x were equal to 5 halves or x is equal to 2. So if I plug this into Desmos, what I'm going to find is, that's what I did here. So we see our equation, and what it tells me is, well, if I look around, it looks like my roots is 2, and then that's somewhere between 2 and 3, so 5 halves seems reasonable. So if I just see the graph, then yeah, it seems reasonable that 5 halves and 2 would be good. Another way I can use Desmos to check that these are the solutions are to just plug it in. So I called my function here f of x, and if I plug in 5 halves, what I should see is an output of 0. So by plugging in 5 halves, I get an output of 0. By plugging in 2, I also get an output of 0. And visually, well, that seems like those match up on my graph. Well, if I click in here and I click on this red graph, my zeros actually do pop up. And so if I click on those dots, what we see is one of my zeros is 2, the other 0 is 2.5, which as a fraction is 5/2. So, all right. I hope this helps, and I'll see you later.